Hey everyone, welcome back to my YouTube channel. In today's video, we are going to continue with our various applications of difference of two squares. And today's video, we'll be looking at how to simplify certain fractions in algebra by applying the principles of difference of two squares. Okay, so there are a few things we can take notes of to help us in answering these type of questions. So the first point says always check to see if you can factor common terms out first, because there are sometimes certain types of questions will require you to factor out some common terms first before you can apply the principle of difference of two squares. Okay, so if you get a question and you can do that first before you can apply the principle of difference of two squares. Okay, then there's this trick you can use, not really a trick, but it helps you to answer the questions or figure out the part you're supposed to focus on very easily. Okay, so usually the fraction you get, either the numerator or the denominator will have one of them will have the least power. What I mean by that is that you may get a fraction whereby for the numerator the highest power will be, let's say, x to the fourth power, whereas the denominator, the highest power will be something like, let's say, x to the second power, right? Usually, not always, but usually the one with the smallest power gives you an idea, right? Okay, so what it usually means is that you focus on the one with the highest power. You try and then get your difference of two squares over there. I'll use an example to explain to you if you don't understand, but let's just take note of the second point. I'll use the first example to explain the second point in a better way for you to understand what I mean. Then you make sure to factorize completely, and then you cancel out common terms only. And then so let's work on some examples. So we'll be using these examples to go through how we can simplify fractions by applying difference of two squares. So if you take the first example, I'm using it to explain the second point in the previous slide. So you can see that for the numerator, the highest power is 2, whereas for the denominator, the highest power is just 1, right? So you can see that for this whole fraction, the denominator has the least power. That's what I was trying to say. So this gives us an idea, or gives us a clue that we are applying the difference of two squares at the numerator side but not the denominator side, right? Because the numerator has the highest power. The same way, if you take let's say the third example, the numerator has the highest power, right? So it means our difference of two squares will be based on the numerator, right? And then we just ignore the denominator. That's what I'm trying to say. Usually that's how it works. You focus on the one with the highest power, you apply the difference of two squares, and then eventually it will cancel out something at the side with the lowest power. Okay, so we can proceed with our first example. So since we know our difference of two squares work, and by going with our second trick, right, or the trick we learned from the second point, we are going to focus on the numerator over here, the numerator, because the numerator is the expression with the highest power, right? Whereas the denominator is the expression with the lowest power. So we focus on the numerator, and then we try and expand the numerator using difference of two squares. Okay, so before we can apply difference of two squares, we know that we are supposed to get two squares and then a minus sign between them, right? So we write this whole fraction as x squared minus 5 squared all over x minus 5. We just wrote the 25 as a square so that we get the difference of two squares for the numerator. And then we can now recall our formula and then use it to expand the numerator. So we just expanded the numerator. We did nothing to the denominator. Okay. So because the numerator has the highest power, we are expanding that one instead. Okay. And automatically you can see that x minus 5 cancels out on both sides of the fraction. We eventually end up with x plus 5 over 1, which is the same thing as x plus 5. And this cannot be simplified further, so this will be our final answer for the first question. Okay. Moving on to number 2, quite similar to the first one, right? So we focus on the numerator. 49 can be written as 7 squared, so you can rewrite the whole fraction as this, which is x squared minus 7 squared all over x plus 7. And then we recall our formula, and then we can expand the numerator to get x plus 7 and x minus 7 both in separate brackets. We can see that the x plus 7 will cancel out on both sides of the fraction, and we will just be left with x minus 7. And that will be our answer for the second question, because x minus 7 cannot be simplified further anymore. The third question, we have 4x squared minus 9 all over 2x minus 3. Again, the numerator has the highest power, right? So we are going to focus on that and expand that side. So we first of all have to make sure that we are having 2 squares, okay? So 4 is the same thing as 2 squared. 9 is the same thing as 3 squared. So we can rewrite the whole fraction as 2 squared multiplying x squared, then minus 3 squared all over 2x minus 3. We've done nothing to the denominator. Okay. We can further rewrite the expression at the numerator side like this, right? We just want to keep them in the appropriate bracket, so we just get difference of 2 squares. Okay. Then we can now recall our formula and use it to expand our numerator, so we get this. Then automatically 2x minus 3 cancels out on both sides of the fraction. Then we end up with 2x plus 3 as our answer for the third question. Moving on to the fourth question, we have x cubed y squared minus 36x as the numerator, and then x squared y minus 6s as the denominator. So for this one, we can see that there's a common term we can factor out, right? And that is x. So we can factor out x from the numerator side and also from the denominator side. So we do that, and then the x will cancel out. So we just brought x out from the numerator side, and we get this in the bracket. And then at the denominator side, we get x1 minus 6 in the brackets. And these two x's can cancel out. Because we are simplifying, they can cancel out, right? If it was an equation, you couldn't have just cancelled it out like that, because it would have affected some of your values, right? But because we are simplifying and it's just simplification, we can cancel it out. Okay, so we cancel it out, and then we end up with that. Then we can rewrite the numerator by putting the x and y in brackets. Then we raise all of it to the second power, and then we get a nice difference of 2 squares for the numerator, and we can recall our formula and expand the numerator, right? So we get xy plus 6 in one bracket, xy minus 6 in another bracket. Then we can clearly see that those two will cancel out. We end up with xy plus 6 as our final answer. So that will be all for the fourth question, right? Moving on to the fifth question. This is a bit similar to the previous one. Okay, it's actually not similar, but yeah, we have to get a difference of 2 squares, right? We cannot get difference of 2 squares from the second bracket. It's not possible, right? We cannot get difference of 2 squares from the denominator side as well. So we only focus on the one in the expression in the first bracket on the numerator side. So we we rewrite 9 as 3 squared, and then we group the 9 and then the m to make it simple. So we now have 3m squared minus n squared, which is difference of two squares. We can recall our formula and then expand that expression in the square brackets. So it's the same thing as this one. So we just expanded this, right, to get this 3m plus n and then 3m minus n. The m plus n is the same thing, we've not changed it. Same thing applies to the denominator, we've not changed that one as well. So we can now cancel out common terms, right? Just 3m minus n on both the numerator and the denominator side. And then we just end up with 3m plus n multiplying m plus n, both in separate brackets. And that will be our final answer. Okay, moving on to the last question. This is also very easy. Okay, now you can see that the highest power at the numerator side is 2, right? Whereas the highest power at the denominator side is also 2. So if you get a question like this, whereby you have like the highest powers on both the numerator and the denominator sides are equal, what you should know is that it means you can apply the difference of two squares on both sides, right? So you can apply it on the numerator side, you can also apply it on the denominator side. Usually what this means is that you can cancel out terms by applying difference of two squares here. You can also cancel out terms by applying difference of two squares at the numerator side as well. That's what it means. So I'm just going to do that, right? So 9 has just been written as 3 squared, and then we group the 3 and then the b very nicely. So you can see that if you check the numerator, we have a squared minus 3b. Okay, this 2 should have come outside of the brackets. So just take notes that this 2 is in here. This 2 is supposed to be here outside this bracket. Okay, right, so that becomes the difference of two squares. And then we also have a difference of two squares at the denominator side, right? So just make sure that you check to see if you can have difference of two squares on both the numerator side and the denominator side. It's not always that the fact that one is bigger than the other, you can't apply difference of two squares. It's usually like that, but it's not always like that. All right, so we can proceed, recall formula, and then use that to expand the two difference of two squares on both the numerator and the denominator side, right? So that is going to give us a plus b. So we just maybe let me disable the pen. Okay, so we just expanded this to get a plus 3b, a minus 3b in separate brackets, and we expanded x squared minus y squared. That gave us this. The rest we just maintain them, right? So now you can see that we can do a couple of cancellations, right? So we can cancel out a minus 3b, a minus 3b. So the ones in blue, we can cancel them out. And then the ones in red as well, we can also cancel them out. And we'll be left with a plus 3b as a numerator, and then x minus y as the denominator, and that will be our final answer. So yeah, that brings us to the end of today's video or today's lesson. We will probably do one more on difference of two squares. I'm not so sure yet, but probably do one more on difference of two squares, where we probably combine whatever we've learned so far and the difference of two squares to solve certain questions. Okay, but before or until we get that video, make sure you subscribe, and if you have any questions at all, it doesn't matter how basic it is, you can leave it in the comment section, and we'll attend to it as well. Okay, so thank you for watching, and I will see you in my next video. Goodbye.